Hello, Slaters. Hope you all are enjoying learning. Slaters, so far we have learned in detail about our Earth and the four natural realms of the Earth. It was very interesting, right? Now, this image shows our Earth as a blue planet. Isn't it, Slaters? Do you think that the description of the Earth as a blue planet is justified? Well, children, Earth is known as the blue planet because of the vast oceans that cover 2/3 of its surface. When seen from the space, our Earth looks like a pale blue dot. And yes, today we are going to learn about water surface of the Earth. That is the hydrosphere. Slaters, have a look at this image. What do you understand from this image? Yes, this shows the freshwater proportion on our planet. Slaters, is it not strange that only 1% of water that reaches the earth is useful to human beings? How do we get this water? To understand this, we need to first learn about the hydrological cycle. Water is a cyclical renewable resource. It can be used and reused. Hydrological cycle is the circulation of water in different forms, that is, liquid, solid, and gaseous phases. The water cycle or the hydrological cycle describes the continuous movement of water on, above, and below the surface of the earth. The hydrological cycle is expressed mathematically as RF is equals to RO plus ET, where RF is rainfall, which includes all types of precipitation. RO is runoff. ET is evapotranspiration. There are 6 stages of hydrological cycle, namely, first one, evaporation, second, transportation, third, condensation, fourth, precipitation, fifth, runoff, sixth, groundwater. Now let us understand about these stages in detail. Evaporation, the process by which water changes from a liquid to gas, is called evaporation. Water is transferred from the surface of the earth to the atmosphere through evaporation. It is the process by which water changes from liquid to gas. The sun's heat facilitates to evaporate water from the water bodies. Water also evaporates from plants through transpiration. Transportation, the movement of water through the atmosphere, specifically from over the oceans to land in the form of clouds, is called transportation of water in the hydrological cycle. Clouds move from one place to another place by upper air circulation, surface-based circulation, etc. Condensation, the transported water vapor condenses, forming tiny droplets and clouds. Condensation refers to the process of water vapor changing into liquid water. Precipitation, the mechanism of transporting water from the atmosphere to the surface of the earth, is called precipitation. It is in the form of rainfall, snowfall, etc. When the clouds meet cool air over land, precipitation in the form of rain, sleet, or snow is triggered and water returns to the land or sea. Runoff, The rainwater travels from mountains, hilltops to the surface of the land. A portion of rainwater is absorbed by the earth's surface. Water travels into slopes in the form of streams, canals, rivers to seas and oceans. The percolated water travels underground and reaches to the water bodies. Groundwater is the water found underground in the cracks and spaces in soil, sand, and rock. It is stored in and moves slowly through geologic formations of soil, sand, and rocks called aquifers. The flow of groundwater is very slow than runoff. Water source. Almost 97.25% of water on the earth is saline, and a mere 2.75% of fresh water is found on our planet. Large amount of fresh water, that is around 68.7%, is in the form of ice and permanent snow cover in Antarctica, the Arctic, and on the mountain tops. Out of 68.7% of fresh water available, 29.9% exists as fresh groundwater. 0.26% of water is available in lakes, reservoirs, and the river systems. So children, water is very precious for life to exist on earth. We need to use fresh water in a very judicious manner and never waste water. Children, though we have 97.25% of water on earth, not all water available is useful for our survival. Have a look at the following data which shows the quantity of water present in the ocean. Continents and oceans are the first order relief features of the earth. The large water bodies are called oceans. The word sea is often used interchangeably with oceans, but a sea is a body of saline water partly or fully enclosed by the land. Relief of the ocean. Children, take a look at the picture. Have you observed that the surface of Earth is uneven? Similarly, the ocean surface is also uneven. The uneven surface of the ocean is called basin. The ocean floor is divided into 4 parts. They are the continental shelf, the continental slope, the deep sea plains or abyssal plain, oceanic deeps or trenches. The shallow, near horizontal seafloor extension from the shoreline to the upper continental slope is called the continental shelf. This slope is characterized by a very gentle slope of less than 1 degree. It is up to a depth of 200 meters. It occupies 7.6% of the ocean basin. It is border zone between the land and the ocean. The largest shelf is Siberian Shelf in the Arctic Ocean. It stretches up to 1500 kilometers in width. The continental slope. A continental slope is the deepening seafloor out from the shelf edge to the upper limit of the continental rise. It stretches from 200 meters to 3000 meters in depth. It is quite complex in its relief. It comprises of 15% of the ocean floor. The continent slope indicates the boundary of the continents. Submarine canyons are observed here. These are formed by erosion process of glaciers and rivers. The deep sea plains. The deep sea plains are also called as the abyssal plains. They are the sloping areas of the ocean basins. These are the flattest and smoothest regions of the world. These plains stretch between 3,000 meters to 6,000 meters and cover over 76.2% of the ocean basin. Oceanic deeps or trenches. Oceanic trenches are the topographic depressions of the seafloor, relatively narrow in width but very long. They are the deepest parts of the ocean floor. They stretch from 6,000 meters and beyond. Most of them are large, narrow trenches. Most of them are found more close to the continents. They are very significant for the study of the plate movements. So far, 57 deep trenches have been explored. Slaters, have you heard about the Mariana Trench? Try and find out about it. Having learned so many points about the seas and the oceans, let us now learn about the salinity of these water bodies. Slaters, many of you must have been to a coastal area. Did any of you happen to taste the sea water? It is really salty, isn't it? Did you ever wonder what makes the ocean water so saline? I really wonder, children, why oceans are filled with salt. Where did the salt come from? And is it the same salt that we use in our food? Now let us learn more about this. Salinity is the amount of salt dissolved in the body of water. Most of the salt in the oceans come from land. Over millions of years, the rainwater, streams, canals, rivers have washed rocks containing minerals, namely sodium chloride, into the sea. Salt in the sea or ocean is mainly caused by rain washing mineral ions from the land into water. Some salts are added by volcanic eruptions into the oceans and hydrothermal vents. A hydrothermal vent is a fissure on the seafloor from which geothermally heated water issues. They are normally found near volcanically active places on the ocean or seabeds. Thus, water from water bodies evaporates, leaving the salt behind. After millions of years, the oceans have developed noticeably salt water. Salinity is the term used to define the total content of dissolved salts in seawater. It is calculated as the amount of salt dissolved in 1,000 grams of seawater. It is expressed as parts per thousand or PPT. The average salinity of the oceans is 35% O in 1,000 parts of water. Ocean water contains 77.8% O of sodium chloride. Slaters, there are some factors that affect salinity in surface layers of the oceans. It is mainly due to evaporation and precipitation, by the freshwater flow from rivers into the seas, by the process of freezing and thawing of ice in polar regions, by transferring of water to other areas through winds, by the ocean currents. Here is an interesting fact for you, Slaters. An isohaline is a line joining the points in the oceans having the same degree of salinity. Ocean temperature. The normal temperature of oceans varies from -2 degrees Celsius to 29 degrees Celsius. The ocean temperatures are also influenced by latitude, winds, ocean currents, unequal distribution of land, and change of seasons. Vertical distribution of temperature. The ocean currents is the general movement of a mass of water in fairly defined direction over a great distance. Ocean currents are classified based on temperature as cold currents and warm currents. The warm currents flow towards the poles and cold currents flow towards the equator. Ocean currents are classified as streams and drifts based on the speed of movement of these currents. The ocean current which flows speedily is called a stream. The ocean current that flows slowly is called a drift. How are the ocean currents formed? Ocean currents are formed based on 4 factors, namely centrifugal force, effects of winds, precipitation, and solar energy. Ocean as a resource. Slaters, oceans serve as vast resources for us. Human beings are dependent on oceans for their food and livelihood since ancient times. Some of the important elements we get from the oceans are salt. Salt is chemically known as sodium chloride. It is one of the most abundant minerals found in the ocean water. Salt can be either directly extracted or could be mined depending upon the different regions. Potassium. Potassium is also an abundant mineral, although it cannot be directly extracted like salt. Sand. The sea beaches can be understood as the residual deposits of sand. Sand is used for different purposes today, such as for construction, recreation, in various industries such as glass making, and so on. Limestone and gypsum. Limestone is a rock composed of calcium carbonate. It is also used in industries such as construction. Gypsum or calcium sulfate hydrate is also used in construction activities and is turned into the commonly known plaster of Paris. Manganese nodules. These nodules contain enormous amount of metal wealth. They can be looked upon as a huge potential to be used by human beings as a resource as and when technology is developed to harness these valuable metals. Gold and diamonds. When the earth was formed, molten iron sank to its center to make the core. This took with it the vast majority of the planet's precious metals such as gold. Also, diamonds in all of the Earth's commercial diamond deposits were formed in the mantle and delivered to the surface by deep source volcanic eruptions. Both of them are in the list of most precious minerals. Water. Although there have been difficulties in the extraction of fresh water from the oceanic salty water, however, the advancement in technology should be able to harness the most important resource for survival of living beings possible at a large extent. Oil and gas. Although we have been successful in some of our attempts, however, a rich volume is left unexplored still, which when done would solve the problem of shortage of fuel to some extent to meet the needs of the growing population. Coal. Coal contains volatile material, carbon, ash, and moisture. It is found in sedimentary strata. Coal reserves are 6 times greater than the petroleum and oil reserves. So Slaters, this brings us to the end of this video explanation. Do watch it twice. Until then, keep learning.